In this video, we're going to be talking about deductive reasoning. We've already talked about logical arguments using inductive reasoning, and we talked about how we use it pretty much every day based on patterns and observations. We think this is going to happen, and sometimes inductive reasoning is not entirely reliable. However, deductive reasoning can come up with much more reliable resolutions. So by definition, deductive reasoning is the process of reasoning logically and drawing a conclusion from given facts and statements. Okay, now let's try to explain that. Using deductive reasoning, we're going to pretty much use the laws. We're going to use the facts. We're going to use the theorems. We're going to use the postulates. I know this is true because this is true. We have evidence, I guess is a good way to talk about this. You have concrete evidence that you can prove something is true with deductive reasoning. A lawyer would want to use deductive reasoning much more than inductive reasoning just because, well, based on patterns, things are not always true. However, if you've got facts and statements that can prove that something is true, then it's much more concrete. Okay, our first law that we're going to use for deductive reasoning. Now, this is going to sound pretty straightforward. It might sound confusing as I'm going through this up here, but this is a very straightforward law that hopefully seems overly easy as we go through it. But the law of detachment says, given a conditional statement, if the hypothesis is true, then the conclusion is true. Okay. If we know that a conditional statement is a true conditional statement. Now, let's write this with what they call a symbolic map. Let me change colors here. If we know that P implies Q is a true statement, and we know that P is true. Okay, we're going to draw a line. That's kind of like we're adding this plus this, and here's what it's equal to. So if we know that P implies Q, and we know that P is true, then we now can conclude that Q is true. Now the three dots that I put there is the symbol for therefore. So let me read this one more time. If P implies Q, which means if P happens, that implies that Q is going to happen. And we know that P happens. Therefore, we can conclude, this is below this, it's just like if I'm doing 2 plus 3, here's my conclusion, 5. If P implies Q and P is true, then therefore we know that Q must be true. Now let's apply that to an actual statement, and hopefully it'll make a little bit more sense. This is again called the law of detachment. Use the law of detachment to give a valid conclusion. If it is not possible, write no valid conclusion. So if we know that if Mark saves $30, then he can buy a new video game. Mark saves $30. Therefore, what is our conclusion? We know since he saved $30, he can buy a new game. That's it. If we know that P, let me put it in terms of P's and Q's. If we know that P implies Q, and we know for a fact that P is true, then what happened? It just implied that Q is true. Number 2, let's do another one. If a quadrilateral is a rhombus, then it is also a parallelogram. That is your P implying Q. If it's a rhombus, then that implies it's a parallelogram. quadrilateral ABCD is a rhombus. If we know that P implies Q, and we also know that P is true, then what happened? It just implied Q. Since quadrilateral ABCD is a rhombus, then that means that also quadrilateral ABCD is also a parallelogram. And I'm just going to abbreviate that there. We'll just do PARR period. Number 3, if you are 18 years old, then you can register to vote. Olivia is not 18 years old. Okay, now this says if you are 18 years old, then you can register to vote. Olivia is not 18 years old. This is not the law of detachment. The law of detachment says if this is true and this implies this, then if we know that this is true, does it say down here that that is true? No, it says it's not true. So I'm just going to put no conclusion for now. Because again, the law of detachment, if P implies Q, and we know that P is true, well, this is not P. This would actually be not P. So let's stay away from that for now. Number 4, if the sum of the measures of two angles is 90. If the sum of the measures of two angles is 90, then they are complementary. P implies Q. So are the sum of these two measures 90? Yes. So what does that mean? That means that it implies Q. That means that angle J and angle K are complementary. Done. Law of detachment. If you plan to attend prom, then you must purchase a ticket. Sarah purchases a prom ticket. Wait a minute, that's not P. P implies Q. If you plan to attend, then you purchase. We know that she's purchased a ticket. Does that mean she plans to attend? No. If P implies Q, and we know that P is true, we know that if she plans to attend prom, it doesn't say anything about Q being true, so we're just going to put no conclusion here. We're going to stay away from, that would be an inverse there. The other one that would be converse. The other one that we were discussing would be an inverse. So we're going to stay away from those two conclusions for now. We're going to talk about another law, the law of syllogism. The law of syllogism allows you to draw a conclusion from two conditional statements in which the conclusion of the first statement is the hypothesis of the second. Symbolic map. Now let me explain syllogism to you in my way. I think of it as like a domino. If the first domino knocks down the second one knocks down the third. Then the first one eventually knocked down the third one. Okay, here's the symbolic map for the law of syllogism. If we know that P implies Q, and we also know that Q implies R, what results from that? P implies Q and Q implies R. Okay, we know again that P was like that first domino that implied that the second domino got knocked over. And that conclusion, by this definition up here, is the hypothesis of the next one. First domino knocked down the second one, then the second one knocked down the third one. What does that mean? That means that pretty much that first domino get knocked over eventually knocked down the third one. P implied Q, Q implied R, therefore P implied R. It's kind of like the butterfly effect, if you've ever heard of that. Use the law of syllogism to make a valid conclusion. If it is not possible, write no valid conclusion. If it is Saturday, then Jake has a baseball tournament. If Jake has a baseball tournament, then he will need to pack a lunch. So therefore, Saturday implied baseball, baseball implied packing a lunch. So therefore, the conclusion is if it is Saturday, then ultimately Jake needs to pack a lunch. So it being Saturday meant that, yeah, it was baseball and baseball implied lunch, but being Saturday ultimately led to the fact that Jake needed to pack a lunch. P implied Q. Q implied R, so therefore P ultimately implied R. If a number is divisible by 12, then it is divisible by 6. If it is divisible by 6, then it is divisible by 3. So therefore 12 implied 6 and 6 implied 3. So what does that mean? That means that if it's divisible by 12, I'm just going to write it like this time. Divisible by 12 implies that it's going to be divisible by 3. If a quadrilateral is a square, that implies that it is a rectangle. If it is a rectangle, that implies that it has 4 right angles. So therefore, ultimately, by the law of syllogism, it being a square, yes, it implied it was a rectangle and then it has 4 right angles, but it being a square ultimately implied that it has 4 right angles. Number 9, if it is sunny this weekend, then then you will go boating. If it is sunny this weekend, then you will wear shorts. So here we had P implying Q, to where P was it was sunny and we're going to go boating. But there's a problem. Here, this is the same P, and it also implied a different thing, R. So is there a connection there? No. P implied Q, and then P also implied R, so there was no connection with these two. This is not the law of syllogism, no conclusion. Number 10, if you shop at Target, then you will use your Target red card. So Target implies Target red card. If you do not use your Target red card, you can already see this is P and it should be implying Q. This is not Q. This is not Q. Then you will not get 5% off. So we're going to go with, again, no conclusion. And finally, number 11, the last one. If it snows, then school will be canceled. So snow, canceled. If school is canceled, which is Q. Okay, here is my P, here is my Q. This is Q. If school is canceled, then students will need to make up a day of school, which would be the other result. So snow implied canceled, canceled implied makeup. So I'm just going to write this shorthand. So the snow will imply that we're going to make up a day. And that is, again, the law of syllogism.